Hello viewers, I am Kausalya. Today we are going to solve example problems in chapter 6 triangles. We start with example 1. If a line intersects sides AB and AC of a triangle ABC at D and E, right, and is parallel to BC, prove that AD by AB equal to AE by AC. Okay, first we split the question. So here we have a triangle ABC, right, whose sides are AB and AC. So first, this is my triangle ABC, right? And it has sides AB and AC. So obviously the third side will be BC. Now, D, you see, line intersects the side AB at D. So this is AB, a line intersects and the intersecting point is D. And side AC is intersected at a point E. So this is AC and the intersection point is E. Now we have to prove, and the other thing is, you see, this DE is parallel to BC, right? This line is parallel to this line. We have to prove AD by AB, right? AD by AB is equal to AE by AC. AE by AC, right? So here, you see, DE is parallel to BC. Here it is clearly given, right? So in a triangle, when a line is parallel to the third side, then obviously we can use our basic proportionality theorem. So what does the theorem says? You see, here the ratio is equal. That is AD by DB is equal to AE by EC. Right. This is according to basic proportionality theorem. So, but what we need to prove? We need to prove AD by AB equal to AE by AC. Right. So to prove that, the first thing what we are doing is we are taking a reciprocal. So when you took reciprocal, you see dB by AD equal to EC by AE. Next step is I am going to add 1 on both the sides. So when you add 1 on both the sides, you see 1 plus this value and again 1 plus this value. The next step is here we are going to take LCM. So when you take LCM, you see 1 into AD is AD. So AD plus DB the whole divided by AD. So which is equal to AE plus EC the whole divided by AE. Right. Now AD plus DB. When you again look at this diagram, what is this AD plus DB? It is AB. Right. Again AE plus EC is AC. So here you see AD plus DB is rewritten as AB by AD and here it is AC by AE. The thing what we need to prove is, you see, AD by AB equal to AE by AC. But here the thing what we got is a reciprocal of it, right? So no issues, just take the reciprocal and finally we got the answer, right? Hence proved. So next example 2. The problem is ABCD is a trapezium with AB parallel to DC. So here ABCD is a trapezium and AB is parallel to DC. E and F are points on the non-parallel sides. So here when you look at the trapezium, the thing is it has one pair of parallel sides and one pair of non-parallel sides. What do you mean by non-parallel here? You see, this AB and this DC, however they are extended, they remain parallel to each other, right? But when you look at these two sides, this AD and this BC, okay, when you keep on extending like this, obviously they intersect at a point. So these two sides are known as non-parallel sides of a trapezium, right? That is one of the quality of a trapezium. So here the non-parallel sides are AD and BC. Right. So E is a point on AD, right, and F is a point on BC. Such that how the point is located, you see, EF is parallel to AB. This line EF is parallel to AB. Right, these two lines are parallel. So we have to prove AE by ED. Okay, AE by ED is equal to BF by FC. Okay, BF by FC. Right, we need to prove that. So to prove that, here we are drawing a line, okay, that connects the points A and C. and this line AC, it meets the line EF at G, right? So here you see AB is parallel to CD, right? This is clear from the diagram, right? Because these two sides are parallel. Next, EF is parallel to AB. This is given in the problem. Okay, this EF is also parallel to this AB. Right. So finally we can conclude that this EF is also parallel to CD, because you see this AB is parallel to CD, and again the same AB is parallel to EF. So what it means? Again these two lines are parallel, right? CD is parallel to EF, right? So this is what written here. Lines parallel to the same line or parallel to each other. So here these two lines CD and this EF are parallel to AB. So obviously EF is parallel to CD, right? Now we are going to prove that, right? That is AE by ED equal to BF by FC. So for this, just we are considering the triangle ADC. So here you see this is the triangle A, D and C. So in this triangle, you see this side EG is parallel to this DC, right? Because this EF is parallel to this CD. So obviously G is a point that lies on EF. Therefore, this EG is parallel to this DC. Right. So when you apply basic proportionality theorem to this triangle, what happens? AE by ED is equal to AG by GC, because this side is parallel to this side. Right. That's the thing. So I had written that, you see, AE by ED is equal to AG by GC. Mark it as 1. Now you consider the next triangle, right? So the next triangle is this, okay, CAB or ABC, right? So again here the same thing, right? This GF is parallel to AB, right? So again here we can apply our basic proportionality theorem. So when you apply basic proportionality theorem, the ratio is, you see, CG by GA is equal to CF by FB, right? So here this is the statement I have written here, right? So just I am taking the reciprocal, right, to get the solution what we need. So here when you take reciprocal, you see just GA is written as AG. Okay, that's it. So this AG by CG is equal to FB by CF, right? So here when you compare the equation 1 and 2, you see here I have the term AG by GC, and here also I have the term AG by this GC or CG, whatever may be. So when the left hand side is equal, obviously the right hand side terms are also should equal. Okay, sorry to say the left hand and right hand, here I have written in the reverse. So nothing, here also this is AG by GC, and here also this is AG by this CG. Therefore obviously this value is equal to this value. So AE by ED is equal to BF by FC, right? This is what we need to prove. So finally we have proved that. Next we start with example 3. So in the given figure, this ratio is equal and this angle is equal. So we have to prove that this triangle is an isosceles triangle, right? So here the triangle is PQR. This is the triangle. So the given condition is, you see, angle S is equal to angle R. Okay, this angle is equal to this angle. And the ratio PS by SQ, okay, PS by SQ is equal to PT by TR, right? So you see, when this ratio indirectly says that this line is parallel to this line, yes or no, by basic proportionality theorem, right? When the ratios are equal, obviously these two sides are parallel. So now the thing here is, you see the angle, okay, when this holds good, okay, when this ST is parallel to QR, you see the corresponding angles, that is this angle is equal to this angle, and again this angle will be equal to this angle, right? So you see here angle PST, okay, this PST is equal to PQR, right? And again the next condition is clearly given. You see the angle PST is also equal to this PRQ, right? So this is given clearly. So what happens, you see, finally this angle is equal to this angle, right? This angle PQR is equal to PRQ. So in a triangle, when these two angles are equal, this indirectly says that the sides which are opposite to this these angles are equal. That is, the side which is opposite to the angle R is PQ, and to this angle Q is the opposite side is PR. So this shows that this PQ is equal to PR. So what is an isosceles triangle? When any two sides of the triangle are equal, then we call it as an isosceles. So here the two sides are equal, therefore PQR is an isosceles triangle. Thank you. If you have any doubt, let me know in the comment section.